All right, folks. This lecture, we're going to focus on reverse engineering. It's something that I think is going to be useful for life and independently from this mobile security thing. So please, eyes open and let's see what this is about. All right. So this class is about the art of reverse engineering. I'm going to explain in a second why I think it's an art and the pros and cons of various approaches. And then I'm going to have some slides about the actual tools and a demo. Okay. Okay. So we talk about the art of reverse engineering because there is no really a single recipe that works in all cases. In general, the goal of this reverse engineering is to understand what X does and how it does it. Let me myself up. Where again, X could be an Android app like in this class, but it could be a Windows program or a specific OS functionality, a piece of hardware, some mechanical physical engine, and so forth. I checked on Wikipedia when I was preparing the slides, and there's the definition they had: process by which a man-made object is deconstructed to reveal its design, architecture, and to extract knowledge from the object. Again, the focus is a very, very vague about man-made object. You can think about physics as maybe the reverse engineering of nature, but you get the point. And again, it's called an art because there is not really one single way of doing things, and it's very difficult to teach. There's a way to do task X, Y, Z, and unfortunately, I don't think there is any shortcut to actually learn how to reverse engineer than actually trying yourself. So basically, these slides are more about high-level mental approaches on how to approach things, techniques, focus on Android security. But again, what I would like to convey is more the higher-level mental approach and mindset when you need to figure how something works. Again, depending whether it's Android app or not. Okay. All right. Again, keep in mind I cannot teach you everything, so that's my best attempt to cover the important parts. But these slides cannot be like the end of your material, just the beginning. I have many links around. So if you've never done this before, maybe it's the beginning of a new journey. But again, don't think that you can just stop here, okay? I've been doing this for 10 years and I'm still learning, and I'm still a lot to learn. Cool. So focusing a bit on Android app, the input of this, usually it's an APK. So we start from an already pre-compiled APK and we need to figure out what's going on. And depending on the task, we may have different goals. We can have, what does this app do? And, from a high level point of view, or maybe want to understand, the tech details. So now an app is doing something specific. Or maybe another task could be to find security vulnerabilities and maybe to find a way to exploit them to gain an actual advantage, okay? And, a bug or a vulnerability, as we'll see later on, could be some way to steal private information or read private files, or to steal and use a permission given to an application A. Maybe a malicious app can actually use this permission of an application A on, let's say, on behalf of the malicious app, okay? So again, the goal can be very generic. So before starting with, I need to reverse engineer this application, you should always ask yourself, what's the goal? All right. Another thing, from a high level point of view, one big advice is don't just start reading everything in details. I'm going to show some tools how to take an APK and to unpack it and see what the instructions are and what actually, what are the, Dalvik bytecode instructions that are executed when you start and so forth. And one common mistake at the very beginning is, okay, let me read every single line of this application. You could do this, but in general, it's a loss of time. Okay, so the idea is do not start just by reading everything, but try to focus on, okay, given goal X, what's the best way to approach this this reverse engineering task. So always proceed depending on your goal. Always ask your question, what is my goal? And here I have a number of potential questions that you may want to answer. For example, maybe you just want to get a generic understanding of what the app does, or maybe you want to find ways to attack the app, or maybe you want to understand how the application interacts with the network, or maybe how the application stores private information, so you can see whether the app is storing them in a proper way or an improper way. Or for example, to check whether a specific functionality is abused in the case of, for example, malware analysis, okay? So I'm gonna try to, in the next following slides, I'm gonna try to zoom in these questions, try to see how I would actually, deal with this specific task. Again, this is just a partial list. There are many potential goals. Of course, in real life, probably you have a mix of these goals, or you don't have only one of them, and so forth. Okay, so keep an open mind. So let's try to understand this generic understanding of what the app does. Well, what I would do is to, again, start from a high level point of view. So for example, what I would do, you take an emulator, you start the app, and you see what are the first user interfaces. So you get an idea about what kind of stuff the application is doing. And then maybe I would check, what is the app supposed to do? Maybe if the application is installed from the Play Store, I would just download it. And then maybe I will go to the Play Store and check the description to see what the app again is supposed to do. And in a way, by doing this kind of understanding, you're going to set your expectations right. In terms of, you expect the app is doing this, depending on what's the context of your reverse engineering task. If it's a benign app, usually these tasks, the tasks that are actually carried on by the app, are somehow in line with the expected, your expectations. And in most cases, it's much easier to understand, okay, this app is doing X, when you know already that more or less it's supposed to do X, okay? So that's like cheating. You check the description and then you try to get an idea. Of course, keep an open mind, because it could be that the app is not implementing what it's supposed to implement, okay? Again, the mindset should be what it's supposed to do, but also, hey, if you notice that it's doing completely other stuff, maybe that's interesting, maybe you should investigate. Okay, cool. Another question was find ways to attack the app. Again, in this case, we will start from the entry points. So try to understand how the attacker could interact with this specific application. Of course, it's a very complicated topic in the sense that you may have different types of attacker. It could be an attacker that can install a malicious app on your phone. So any malicious app, how can a malicious app on your phone interact with your target app? Or it could be an attacker on your Wi-Fi network, or it could be an attacker that can insert a physical USB cable in your phone. So this is a more complicated topic. We're going to explore this in detail later on when we try to discuss vulnerability analysis, threat models, and so forth. But again, I hope you get the point. Depending on the goal, depending on the scenario, depending on what we'll call later threat model, we need to enumerate the entry points. So how can an attacker interact with your application? And then basically we would take it from there, okay? In general, what I would do is also starting from the entry point of the application flow. So we start from the activities, for example. We check the activities, we check what's the main activity, so we know that the app is supposed to start from there. And then we ask ourselves, okay, can a specific functionality can be reached by another application? Then another thing would be to see how this application interacts with the external world, because maybe there are some problems in the way this interaction is carried on, and the attacker can jump in and do something bad. Okay. Again, external world, I mean it in the in the very broad sense. It could be talking to the network, or writing a file, or writing to another, contacting with another application. Okay. Okay, another question was, how does the app interact with network endpoints? That's a common question, trying to see, for example, if the app is just sending something to the network, or if it's downloading something to the network and then executing it. And again, there are a bunch of potential starting points. One thing you could do is to try to find IP addresses or URLs in your app. Again, they could be obfuscated depending on your context. So if the app is not obfuscated, maybe you can just do, you unpack the app, you do grep HTTP, and then you find a bunch of URLs. But if the app is obfuscated or potentially obfuscated, this may not be enough, okay? You are not gonna see the HTTP in clear. In general, no matter what you do, just looking at the PK may not be enough. And a scenario could be, for example, where the app, for example, downloads something from the network and then runs it. And of course, if you just look at APK, you are not going to have the content downloaded from the network. Okay. Another thing is to start not from the endpoints, from the URLs and forth, but from the network APIs. So you could start grabbing, for example, for APIs that you know are associated to internet requests. For example, open connection and things like this. Of course, it's tricky because how do you know them all? You need to have a list, and again, they could be obfuscated. Another potential way would be to take the app and run it in emulator, and you start monitor network activities. Okay, that's another way. Again, we're going to see how to actually do this later on. As of now, I want you to develop like a sense of what are the potential approaches to solve a specific task. And again, remember that just by running it may not be enough. For example, if you have an app that before running this network activity, you need to go to a specific point in the application. Well, just by starting it, you're not going to see any network activity. So please keep it in mind. Another question is, how do you store private information? Again, what is private information? Again, it really depends on the context. So if the app is, kind of a password manager, it's about password. If it's a contact list application, then it's about contacts. It's about a camera, then of course about pictures and videos, and so forth. So again, if somebody asks you, how does the app handle private information? You should always try to figure out first what is private information in this context, and given this answer, then you can zoom in and focus on this specific thing. For example, if the app is like a contact application, maybe it doesn't make any, and maybe doesn't have the permission to access the microphone or the camera, then maybe it doesn't make any sense to just focus on, let's see how we store pictures, or let's see when it can acquire a photo. Okay. So again, try to get the context of what you're supposed to do, and then use this information to zoom in and go deep in what you're really supposed to be doing. Okay. And again, once you know what you're looking for, then it becomes like the network case, where basically, okay, I want to check how this app is, managing photos. Okay, let's list all the APIs that are supposed to acquire photos or access the SD card. Okay. Another question was, check whether a functionality can be abused. Again, very similar to previous cases, but a bit more targeted, because usually they tell you, okay, check whether this specific functionality, and so you can focus on that one. So you can do your analysis more targeted, and you can ask yourself, how does the app use functionality X, or does it use it in unconventional way? Unconventional way could be, what is the a proper way of implementing functionality X, and then you ask yourself, does this app actually follow the conventional and proper way X? If not, well, maybe it could be just crappy code, but it also could be that it's actually vulnerable and potentially insecure, maybe intentionally potentially insecure. Okay. And then of course you should also ask yourself, how can an attacker reach it? If the context is potential, like finding vulnerabilities and so forth. So in general, there are some suggestions. The suggestion is to have a top-down mentality. Start with a high-level understanding of the app's organization functionality. So what I usually do is to check, okay, how many activities do I have? If they're like 1,000, problematic. If I have 3, then I can actually try to run the app and try to play with it until I find all the 3 activities. And so I get an idea about what these 3 activities are supposed to do. And then depending on the context, maybe I say, okay, the first activity is just maybe the login page, then let's focus on the second one. Once you have these entry points, then you can explore the different functionalities, explore the app as a user, so you play it around it, and again, you can try to enumerate how can attacker enter. And again, some of these questions may not make sense depending on your context, okay? So keep a flexible mindset, and don't read code just because you need to reverse engineer stuff. Before going all in the actual technical thing, try to think about what you're supposed to do and where is potentially the best way to start with. And again, usually it's not reading every single line. Now, if it's a very simple app, maybe, yes, maybe you can start reading every single line. It's much easier than just wondering, oh, maybe I should start from the 100 instead of the 105 or instead of the 50th line. It doesn't matter. But if you have a, you know, a reasonably non-small application, then maybe it's better to you know, to think about it before starting randomly from the first line. Okay. During this, this class so far, the slides, I guess that some, you know, you've seen some patterns in kind of the two approaches that one could take. And the two approaches are static analysis and dynamic analysis. It's a broad characterization. Some kind of analysis are like in the middle, but you get the point. You will get the point about this static analysis and dynamic analysis. The idea is that static analysis, you inspect the app without running it. So you take the code, you unpack it, and then you use your tools to understand, okay, this app is doing this app is doing that, and then you look at the code and so forth. Dynamic analysis is more on you take the app and you run it on emulator, and then you see what it does. And maybe you try to understand, if it's opening network requests, if it's writing some files, and so forth. Okay. These approaches are complementary, and as I'm going to explain better in the following slides, taken independently are very limited. Okay, so there are many scenarios in which you really need to use a combination of both static and dynamic. In many cases, maybe you could use only static analysis, but it would be much easier to do it with dynamic analysis, and vice versa. There are many cases in which you could do this dynamic analysis, but if you do it statically, it's much easier. Okay, and again, the key skill to learn in life and for this class is to understand which one to use and when. Okay, so there are some specific kind of tasks that you need to realize, hey, bam, this is more for static analysis, or other tasks that are, hey, this is more for dynamic analysis. And so basically the next slides are more about pros and cons of this analysis, and when I would suggest you to use static analysis vs dynamic analysis. Okay, again, it's a skill to learn. You cannot stop the slides. You need to try out, and the second homework on reversing apps is going to be about this. It's a process, and it takes many years. And I've been working security for 10 years now, and of course I'm still learning. And there are always people that can teach me, there was this trick, and you would have been 10 times faster in solving this specific challenge. Okay, so keep your mind open. All right. Quick overview on this static and dynamic analysis, and some examples on when static would be more powerful than the dynamic one. So the key point, as I said, is that you do not run the app, okay? And so you inspect it statically. So this usually means that you take the app, you unpack it, and then you check what's inside. So you would read the manifest to see what kind of activities, services, and other components you have, what kind of permissions you have, and so forth. And you disassemble or decompile it. You check the native code. Again, future slides are going to be on this, etc., etc. Okay. Dynamic analysis, instead, you actually run the app, as I mentioned. So you want to know what's going on at runtime, and it's more dynamic, and that's where the dynamic analysis term comes from. And you usually would like to know what is the value of this variable at this point when I actually run it. And that's actually quite useful if you have obfuscated things. So if you have some kind of form of obfuscation where instead of having a URL, you don't have http google.com, but you have blah, 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 and then there is some code that takes this blah, 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 and modifies it and creates some URL that maybe ends up being http google.com. Well, instead of reproducing this decryption or decoding of this blah, blah, blah in http google.com, maybe you can just run it. And if you can print what's going on after this decryption or decoding, then your life is much easier. That's one example where dynamic analysis is more powerful, okay? Other things you may want to do is to trace the API invocation. So there are tricks to just say, please, I want to know the list of all the APIs that are invoked. And again, depending on what kind of APIs are invoked and with which arguments, then you may get an idea about what the app is supposed to do or what the app is actually doing. Trace of syscalls. for Linux programs, there is strace. There are other frameworks for Android apps, and the idea is to list all the syscalls or all the interactions with the from application perspective to the operating system that are going on. And again, you get an idea. Pros and cons. Dumping APIs, there are many. If you dump syscall, even worse. There are so many syscalls being called. Many of these are actually called not by the app, or I mean, they're called by the app, but they're called indirectly. They're called from the framework. So the application call API X, and then the framework somehow calls tons of different syscalls. And it's very tricky to actually map which syscalls actually correspond to which API. From the high-level perspective, though, we can characterize these techniques in two groups. One is debugging, and the other one is instrumentation. Again, we're going to explain this better. Debugging. So the idea is that you run the app on an emulator or a real device, and then you attach a debugger. If you have followed MOBISEC or other binary analysis classes on the internet, you're going to probably be familiar already with the concept of a debugger. So you have a program, and then you can attach with a debugger, or you can take the app and you run it within a debugger. And then the debugger is a ways to say, okay, execute each instruction at a time, or please tell me the content of this register or of this, piece of memory at this point, and so forth. And so it's very, very powerful technique. You can say something like stop the execution when you reach point X, Y, Z, or again, tell me content of this field or memory location. And again, maybe in other classes you've seen debuggers, and here the question there is more, oh, can I see the value of this register or of this memory? In the context of Android apps, depending on your setup, you can have a debugger that somehow knows about the object-oriented things, such as a field. Okay. Again, you can maybe I'm going to show you the demo. You can debug with Android Studio, and you're going to be able to see, please stop the execution here, and then you have a view where you see the values of the fields of each object. Okay. Again, you can do single step and so forth. And it's very, very helpful to understand what's the state or context of at a given point. Okay. Instrumentation is a bit different, and is also very, very, very powerful. Let me move on myself. And the idea is that you run the app in an instrumented environment. What does it mean? Well, the idea is that you run the app in an environment like in an emulator or in a modified device in a way that something happens, or some kind of trace or some kind of logging happens. One example could be that you run it in an instrumented environment so that every API invocation is traced. So you have the list. Or every network-related API invocation is traced with all the arguments. So you know if you're contacting Google and what you're sending to it. Or you can log all the strings that are used. Or you can dump information about, you can dump information only when specific conditions are met. Please keep in mind that, you could say, awesome, all the strings, great. Oh, all the APIs invocation, great. Too much information is not always good. It could be that if you try to log too many things, everything is going to be so much slow that your app is gonna start not responding anymore, and so forth. For example, if you try to do the syscall trace of all the syscalls executed by an app, you're gonna have a slowdown that is significant. Okay, maybe a trick is not to log all the syscalls, but maybe one type of syscall. Okay, so don't take this as the only potential ways. These are more examples, and usually the actual trick is to focus on what you actually really need and try to instrument only on this specific aspect, so that you don't increase maybe overhead, and you don't get overwhelmed by the quantity of data. Okay. Let me turn off the phone. Okay. Cool. Again, there are many technical ways to achieve this. One way could be to take the emulator and you modify it, or you instrument the art environment, or you actually modify the app itself. And again, there are two categories, let's say. There is one that we could call manual instrumentation and instrumentation frameworks. And let's see if I and in manual instrumentations, what we do is for example, we take the app, we unpack it, and we insert something that somehow is going to tell us something about the context. For example, the content of a specific variable. Again, we're going to see this in the demo. And then there are also frameworks that somehow allow you to abstract the way how you do things. You can just specify, you know what, please, when you call method X, print this string or print me the arguments. Again, these are two different ways. They could be, they are both very powerful, but which one you should use really depends on the context. In general, it could also be considered as an open problem, in a sense that if you just have a benign app, then I think everything is fine. If you have a malicious app, then it's an arms race, because many of these instrumentations could be detected. So both manual and with the framework. Okay, so if it's manual, you are modifying the app, and so an app can say, it can detect it has been modified, and so you're gonna stop doing the malicious thing, for example. Same for instrumentation frameworks. All the frameworks I'm aware of can be detected because they leave artifacts maybe in memory, and so the app can actually find these artifacts in memory and somehow mess with it. And of course, if the reverse engineer sees these attempts of the malware to bypass these frameworks, then it can take action. And so you can have the malware would use anti-debugging techniques or anti-instrumentation techniques, and the good guy would use the anti-instrumentation techniques. Again, that's where you see the arms race kicking in. I have some slides to summarize the various pros and cons. Static analysis, big pros. It's great to get an initial general understanding of what the app is supposed to do, or in general, you check the activities, permissions, and so forth. But again, also dynamic analysis could be used for this, because you start the app and then you see what kind of, the first activity is going to be login. Great, the first activity is login. Okay, so that's not peculiar of the static analysis. It's again, depending on what kind of stuff you're trying to get, both static and dynamic could be useful. Another pro is that if you're trying to understand again what an app is doing from a level perspective, or getting some semantics, could be useful, or determine which points are interesting. Because with dynamic analysis, you need to know where to go, or maybe you have many buttons, which one to click. Maybe with the static analysis, you can first figure out, button number 3 would lead me to these interesting things, and then I'm lost. I don't know what's going on. Well, then maybe you can switch to dynamic analysis and you click on button number 3. But see, the idea of clicking on number 3 and not on number 1, number 2, and number 10 comes from static analysis. Okay. Other example is when you want to answer questions such as, how can I reach a specific point in the code? Again, if you maybe have an activity and then something fishy is going on, but it's too complicated and you want to actually run it, well, in general, it could be tricky, right? It could be that if you just start the app, you have no idea how to navigate in a way that you are going to reach that specific activity. And again, that's when static analysis could kick in, because you are just interested in to go to this activity 4, I need to get to activity 2, and then to get from to activity 2, I need to get from activity 1, pressing this button, putting this text in this maybe text widget. Okay. The other thing is finding security vulnerabilities. Again, depending on the class of vulnerability, static analysis could be much more effective, because you really need to see the code. Maybe with dynamic analysis, you're not going to see anything, because you run the app, but unless you really have a malicious payload or a malicious string or malicious content sent by an attacker, nothing bad is going to happen. So if you just take the app and you play with it, you're not going to notice anything. There are some cons, of course. It could be that there are some values that may be very difficult to determine in static analysis time. Again, it could be some kind of sort of obfuscation, where maybe this code takes variables from X, Y, Z from the network and so forth, and it could be very tricky. And as we'll see in the next slide, dynamic analysis, bam, you just execute it if you can reach to the point, and you already have the obfuscated value. Again, obfuscations, complex algorithms, that's where static analysis sometimes is problematic. And again, some of these pieces that are useful for the obfuscation and so forth may even not be available in the app itself. It could be that coming from the network. It could be it's a hard-coded file that is decrypted at runtime and so forth. Okay. Yeah, that's what I just said. Dynamic analysis, again, pros are you can dump values at runtime. If an app is supposed to open an internet request to some URL, static analysis, maybe it's tricky, right, to understand what's the actual URL. A dynamic analysis, at runtime, when the app runs, this value needs to be the real one. If this value is not the real one, the app is not going to work. The app cannot actually reach out to the URL. Okay, so if you can get the app to that specific point and you can log it, then you win. You know the obfuscated value no matter what. You can dump network traffic, both sent and received. For example, if you know that there is an app that downloads another stage from the network, well, maybe you can log what's going on and you can dump the actual file that is received. And there is no real reconstruction needed in terms of weird things and so forth. If you manage to put some instrumentation at the output of the network request, then really you can get the payload in a clear way. You can also, with debugging, you can stop analysis at any point and do some kind of targeted context and memory introspection. So it's not just you run it and then you wait. And then you can also some kind of study the reachability aspect of the app. You can ask yourself, well, is this piece of code actually ever reached? What you can do is to put a breakpoint, or you can put a log, and then you try to run the app, and then you see. If you see the log, you know for sure this was reached. Okay. Another question sometimes is, okay, I know it's reached, but with which argument? Again, you put some logs to log the arguments, and you get an idea. And the other idea would be, once you find the security vulnerability, would be nice sometimes to be sure that it's actually exploitable. And sometimes the being sure means developing a proof of concept. For example, you have an app that is supposed to be vulnerable to leaking your pictures, okay? To be really, really sure this stuff actually works, the nice idea usually is you develop a malicious app that send something to your target app and to see if you're actually getting back the picture. So if at runtime you can actually see the pictures there, then the attack actually worked, okay? Without proof of concept, sometimes you may convince yourself the attack actually works. Well, maybe there is some specific aspect for which it will not work, okay? So usually that's why people ask for proof of concept when you claim this stuff is vulnerable. The cons are, again, limited code coverage. That's a famous cons of dynamic analysis. And, is where should I click? And which input should I insert? If you have a login form like username and password, clearly you need to put username and password. But if you have another text box and you have no idea what to put in, then that's when you switch back to static analysis and they say, maybe, okay, let's check how the value that I would put there is actually used, and maybe this value is checked against a hard-coded credential. So in this way you get an idea, but the dynamic analysis itself is very tricky to understand what's going on. Another idea is, how can I reach a specific point? Again, it could be tricky, and then static analysis could kick in and help you out. And the other thing is what I'm seeing bad or not? That's it's a problem of missing the context. With dynamic analysis, you can log what you are reaching, but for example, if you just see in the logs, oh, there is a network request, it's very tricky by just seeing this network request to say this is malicious or not, depending on the context. Because sometimes it could be perfectly okay, but sometimes, depending on when this is invoked, you could say this is absolutely malicious. Again, this is some context that usually dynamic analysis frameworks don't give you, and that's when the human kicks in the static part and says, this network connection was performed here in an activity where the user would never expect it, so it's malicious, okay? And the cons is that it can be evaded in the sense that, again, there is an arm race where basically the malicious app could detect you're trying to debug it or instrument it. Again, for each debug or instrumentation, there are many tricks in a way that the malicious app can say, I'm being under debugging, so I'm not going to do the malicious thing. Or I'm being instrumented by this framework, or I'm being modified, then I'm not going to do this malicious thing, or I'm going to do something slightly different, and so the user is confused, things like this. Again, on the con side of the static analysis is that some things are very, very obfuscated, so it's very tricky. That's where dynamic analysis is useful, because if you manage to run it, it's going to run the deobfuscation for you. But again, you need to pay attention, because some malicious app may try to catch you, okay? That's what makes it fun and terrible at the same time. So the usual workflow, and I guess at this point you got it, is that you usually start the static analysis quite quick, and then you move to dynamic analysis, and then use some insight from dynamic analysis to guide your static analysis, and vice versa. And then, you know, you see, that's interesting functionality, let me reach it dynamically, and then you see what it's doing, and so forth and so forth, okay? So these techniques are very powerful when used in a complementary way, and they have their own limits if used independently, and that's why, you know, people actually use them in a complementary way. And again, the key skill to learn is to understand which technique to use at which time. I hope these slides are helpful, but of course they're not going to be the end of the road. You know, the best ways to get the experience: go out there, solve CTF challenges, check the links I have at the end of the slides, try to get real malware from the internet, and try to reverse engineering how it works, and so forth. Okay. Cool. Again, I'm trying to, you know, discuss in depth the static, dynamic, and pros and cons, because in terms of technical things, there are many resources online, like how to do X, how to do Y. And so I, you know, what I really want to make sure that I do is to convey and explain what I think is not very, very well explained online. Again, not because there are not good resources, but because there is a lot of insights that, if not explained in different ways and from different perspectives, is very difficult to convey, in my opinion. So up to now, I try to systematize pros, cons, when it's usable, and so forth. I have some other examples when to explain when technique X will be useful instead of technique Y. Okay, so trying to make sure that you get the point. So let's consider an app where you have an activity with an access code, input field, and a button. Now, if you just have this, you have an app, and then there is an access code and a button to say, you know, go next. You're kind of stuck, right? Because, you know, how can you know what kind of access code you need to put? That's, you know, and maybe, you know, in this context, you know that there is some interesting and protective functionality after this activity, after you pass the button. And then if you just press the button, it says, you know, access code is wrong. Then you could start checking, you know, what's going on. If you click around again, you're basically out of luck, because if you click around, you're gonna get access code not valid. So the trick here is to go to static analysis and try to see what kind of code follows this. You know, get the access code and check it maybe against something, maybe send it to some online website and so forth. Okay. On the other side, if you have the, you know, the check that actually does, is this access code correct? If this check in the app is actually very, very complex, the static analysis is going to be tricky. And that's why you maybe want to mix them. You want to know, okay, this functionality is the one that checks whether the code is good or not. Maybe let me try to dump some intermediate values so I know better what's going on. Okay. Again, that's the basic loop. All right, that was the last example I had. As always, are there any questions? No, I keep winning the best professor award. Fantastic. So some practical stuff now and some technical tools. All right. So we talked a lot about APKs. As of now, you know how to code your app and how to get an APK out of it. But where can you get APKs in general? Not just the basic ones you write. Okay, I have listed a bunch of links here. So first of all, you can get an APK for any app on the Play Store. So if you have your favorite app, you want to know how it works, now you can. Okay, so what you can do, you go on the Play Store, you install it, and now it's on your device. So on your device somewhere, there is the APK. If your device is not rooted, it's tricky. I have some slides, but absolutely doable. So hold on a second on how to get the APK out of your device. Here there are other links where you can get some APKs to play with. APK Mirror is one resource. Playdrone was very cool, but I mean, it was like a huge data set of apps crawled from the Play Store, like more than 1 million. And I think it's dead. The link is still up, but I couldn't find where to download them, so I don't know. And then there are two other resources, Android Zoo and Kudos. They're like repositories of apps, so you can check them out. And also there are some resources of mailing lists and so forth where security researchers share malicious files, for example. Okay, so you can also see them online. Maybe somebody sharing APKs online. Okay, let's focus on how to get an APK out of your phone. So once you install an APK, usually it lives at a folder like this: /data/app, and then some kind of weird string with some weird name, and then /base.apk. Example for Facebook, it's something like this on my phone when I did the slides. Data app, com Facebook Katana, which is the package name of Facebook, and then some kind of random stuff, /base.apk. So if the device is rooted, or if your emulator is rooted, to access to this one is quite easy. You just cd, or you try to list the files or directories in this /data/app, and then you have a list of things. You're gonna see also com Facebook Katana, blah, blah, and then you can just, you have the path. You can just grab the base.apk from there. If the device is not rooted, it's a bit tricky. Why? Well, try to get a shell with the commands we've seen last time. If you do ls data app, then you're gonna get permission denied. Why is it the case? Well, it's interesting, right? Because if you do ls data app, permission denied, but you can actually do cd data app, that actually works. So what's going on is that if you check the permissions of this data app, they're going to be like this. And the shell user falls under these others, and you see the X, you don't see the R and the W. So the X for directories, as you probably know, means that we can cd, change directory in that directory, but the fact that we don't have the R, the read, means that you cannot do the list. So somehow, if you do list of the content of this directory, it doesn't work, again, because we cannot read from this directory, but we can cd into it, okay? As long as we know the actual path. But that's a problem, right? Because this com Facebook Katana, blah, 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 is complicated, we don't know it. So how can we cd into it without listing it? Well, that's when the other tricks kick in. Basically, there are commands to somehow get information out of the packages you have installed. And so, for example, with this one, you can get the list of packages that are installed. I think it's quite complicated. I mean, there is another, I think it's ADB shell PM list packages should also work. I think that's an old one, but this should still work. Once you have the list of all packages, the apps installed, again, here you're gonna see only the list of package names. Then you can run this other command, ADB shell PM path com Facebook Katana, and this is gonna get you the path of where this app is installed on your system. And it's gonna dump exactly that kind of weird folder name, and now you know where it is. So you can actually pull the file out of your phone, okay? Again, please remember, when I do ADB shell PM, it's equivalent to do ADB shell. Now you have a shell in your device, and then you can run PM path. So remember, PM is just an executable inside your emulator or inside your device. So this ADB shell PM is more a shortcut to run the command directly from outside. But again, you could do ADB shell, and then you can run these commands per se. And then again, once you know this, you can do ADB pull, which take a file from inside the emulator or device, and you pull it out. This is the Facebook APK in this case, or it could be the APK that you're trying to get, okay? This trick works also if your device is not rooted. You just need to have a shell access, which most phones somehow allow. You may need to enable it, USB debugging, depending on your phone, Google for it, but you get the idea, okay? Cool. So how can you install apps from the Play Store? Might be seeming a dumb question. Well, if you have a real device, it's very trivial. You just go and you install it, and that's it. If you don't have a real device and if you have an emulator, the easy way is to install an emulator with Google APIs. I've shown in the first class that usually when you select the image to start from your emulator, you can select Target API 28, let's say, and then there is Target API 28 Google APIs. The one with Google APIs, the pro is that it comes with all these Google apps, including the Play Store, but it's not rooted. So you can be slightly trickier to do some things, but again, you can do what I just shown. The other one was to install an emulator that is rooted, and then you need to install your Google apps separately. And there are these links that somehow show you how to do it, okay? But again, usually what I do is for some deep experiments, I have my rooted emulator. And for some quick things like grabbing an APK, I have the non-rooted emulator, okay? All right, some tools about static analysis. So usually it's really, you take a APK tool, as I shown last time, you unpack it, and then you check what's inside. The manifest, you have permissions and activities, components, and so forth. So you can, it's enough to read the manifest to have the list of components and what's the main activity, and maybe if these components are exported or not, if they define intent filters and so forth, or if there is maybe a broadcast receiver that starts when you boot the phone, okay? Other folders, assets, resources, and so forth. Strings, so you can check maybe the strings.xml to see what kind of strings the app is using. If you see something that is weird, maybe it's already an interesting point. Again, usually I would not start from this resource of strings except for seeing really weird stuff like base64 encoded things. But usually what I try to do is to try to see if some of these are referenced in some interesting way, and then maybe I go all in and I try to see what's going on, okay? Again, I would check for weird things, but I would not lose much time at the beginning. Then there is, of course, classes.dex. If you have bigger APKs like the Facebook app, you're going to also have classes2.dex and so forth. This is because there are some technical limits. I think the limit is that you cannot reference more than 65,000 methods within one classes.dex file. That's a limitation of the Dalvik, specification. But somehow they modified it so that you can have multiple classes.dex, and that's why you have classes 1, 2, 3, and 4, and so forth. Okay. This is, of course, where the juicy part is. That's where the code is, and there are many tools, several tools to actually dig deeper in this. Then we have the native code. Usually, you have a libs folder with several, shared objects. I have a set of slides in the future on this, so hold on this part. And then there is this meta-inf folder, which contains information about certificates and signatures. Let's dig a bit better first on this classes.dex. Again, we've seen them, most of them last time with this APK tools, Smiley, Bagsmiley, and so forth. And that's usually, the tools that people use. Okay, you first disassemble it, you first decompile it, and so forth. And the idea here is that you start from the main entry point and you try to understand what's going on. And at the end, it's normal to use, strings and grep depending on the context. And the idea is to collect some information about the dynamic analysis. Okay, and for example, if you know that one specific activity is the weird one, and it's the one for which it seems interesting and you want to reach it dynamically to see how it looks like, the static analysis focus should be, how can I reach this activity in the fastest way possible? Okay. There are sometimes non-trivial aspects to reverse. This could be encrypted strings or values, complex algorithms. There should be a reference to the X/loader, which is this class in Android that allows you to take another piece of bytecode and to load it at runtime. And somehow then you will need to analyze the file that is being loaded, reflective codes, and so forth. These are tricky to reverse with the static analysis, but as I tried to mention multiple times, this could be easier with dynamic analysis. Because, for example, reflective codes, well, you can put the log and which method you are trying to invoke, and the arguments are going to have them. Okay? Encrypted strings, great. At some point, the strings should be used in the code. So if you somehow put the log in where this string is used, you're going to see the in clear string there. Because if the app is supposed to use it in clear, you're going to see it in clear. There is no way that you can still use the encrypted one. Okay? Again, native code reversing, as I mentioned, we have slides later on this. It's trickier to reverse engineer, and at least it's easy to detect its usage in a sense that, if from the Java part, you are gonna reach the native code, there should be some kind of native keyword in terms of method, in terms of the access flags of the method. Again, what this native is, we're gonna see it next time. And you're going to see calls to system load library that somehow loads the native code library. Okay. Again, I have more things later on, but of course you cannot just grab for load library. Why? Because this method could be obfuscated. So maybe they're calling load library through reflection. And so if you just grep for this, you're not gonna find it. Okay, so keep this in mind. We have more slides later on. And then last, we have this meta-inf. Usually, I'm not using them very often to reverse engineering, but they are important metadata if you want to track, for example, if an app has been written by the same author of another app and so forth. So you usually have 3 files, the manifest, the certsf, and the cert RSA. Manifest is really the hash of all the files inside the APK. So if you open it, you really see a list of files, and for each of these files, you have the hash, okay? Then you have the cert.sf, which is basically the manifest, but it's signed. So it's signed by the key. And then the cert RSA is basically the public key used to sign the certsf, okay? So sign with the RSA key. The RSA key is actually the private key, and that's the one you don't have. And so these files contain, okay, this is the expected hash of each file. So in this way, you understand if something was corrupted or modified. So if you modify one file, the hash is going to change, and the signature is not going to be valid anymore. And again, this cert.rsa contains the public information, like some sort of certificate. So it's the public information plus some metadata about the author. You can dump the content of this with this command, OpenSL, and again, to verify that an app is actually signed properly, you can use this APK signer verify program. Okay. Again, what does it mean properly signed? It means that first of all, the hash is matched. So if you take the hash of all the files in the APK, match the ones specified in the manifest and in the cert.sf, and that you can verify that this signature is produced by the public key listed in this cert.rsa. Okay, how to do this? Well, there's the crypto magic we discussed at the very beginning, where basically you can verify whether a signature is valid, and valid for, you can have the message is supposed to be signed with a given signature, and you have the message, the public key, and the signature, and this verify primitive tells you, yes, the signature comes from the private key associated to the public key I'm listing here, and is actually a signature of this specific message. Okay, cool. All right, so let's try to dig deeper about some concepts that maybe they were not very clear at the beginning, but I hope they're going to be clearer now. In the past, I mentioned that there are some apps that are system apps, and these system apps, I keep mentioning that, are basically like normal apps, in the sense that they are in userland and they invoke the kernel as the other apps, but somehow they have some more permissions and so forth, and they run a system. So how can the framework knows whether an app is a system app or not? So the trick is that an app, to be a system app, needs to be signed with a system certificate. Okay, and by definition, or the way it's coded in Android, is that system apps are these apps signed with the same certificate as the app with package name Android. So basically, once you have a phone, an emulator, or an image of Android, somewhere there is an app with package name called Android. That's it, just Android. Okay. Usually this app lives here, system, framework, REST, APK. So that's an actual APK. And again, the package name of this is Android. And this app, as every other app, is a signature and is signed by a private key. Okay. With the private key, you don't have it, but you have the public key. Okay. So in the APK, there is written, hey, this app is signed by the private key associated with this public key. And the idea is that if your app is actually signed with the same private key associated to the public key that signs this Android app, then you're a system app. Okay, so that's it. And usually you cannot, your app cannot become a system app because you don't have the private key. So you cannot produce a valid signature for your app. Only the Android people, or whoever compiles this can do this, but not you. Okay, and that's where the security comes in. Okay, if you could generate an app that's somehow signed by the private key that signed the system app, then your app becomes system automatically. Okay. The other thing that may not seem related to this topic, but it actually is that You remember at the beginning, I mentioned, there are various types of permission, there are dangerous permissions, signature permissions, and so forth. And I said, oh, if you are an app that is a system app, then you get this permission. And these are the signature permission. The definition of signature permission was actually, you can get the signature permission if and only if you are signed by the same certificate that signed the app that define this permission. And it turns out that all these signature permissions, which are very dangerous, are actually defined by the Android app. This Android app, this framework REST.pk. And this framework REST.pk, it happened to be signed by the system certificate. So long story short, for you to get this signature permission, you will need to be signed with the key that signed the Android application. Okay? And that's why sometimes people confuse this, oh, it's a signature permission with only a system app can get it. Well, yes, only a system app can get it, because the definition of signature permission is not, oh, you need to be system, but you need to be signed by the same permission and defined these permissions. And it turns out this framework REST.apk with package name Android is the app that defines these permissions. You can check the Android framework code. You're going to see a huge manifest with permission. There's the permission definition for all the permissions you're aware of. Okay, cool. I hope it's clear. Some notes about dynamic analysis. Okay, so we have the debugger kind of thing. You can set breakpoints, single step, check runtime values, and so forth. If it's your own app, then it means you also have the source code. What I usually would do there is to use Android Studio. It's great. I'm going to show you this in demo, where basically you can literally, you run the app, you put you click somewhere, and this is going to be like a breakpoint. And basically once the application goes there, basically you're going to stop there. You're going to be able to inspect fields and so forth. Then you can do single step. You can go within a method out and so forth. It's great. Again, you can just start it instead of normally you start it in debug mode, and that's it. Again, I'm going to show you how it works. After you do debug mode, Android Studio is going to auto touch it, and then you can really do single step in a nice way. If it's not your own app, it's trickier. There are custom plugins for IDA, but it's very expensive, so we're not going to cover it. I found some links when I tried to write the slides from NetBeans. It seems horrible. It never managed to work, so screw it. What I usually do for debugging a specific piece of code is that usually I try to decompile it, and then I somehow have the source code of this, and then I import it in an empty project, and now I'm back with using Android Studio. Okay, this does not always work, but in many cases it does. Okay, and again, there are other ways to debug things or instrument things, so sometimes this stuff is enough. I have a link somewhere that also shows how to import an app without source code and debug the Smiley code. I'm gonna send it later, or I'm gonna update the slides later on. Okay, in terms of instrumentations, again, there are several things like running API trace, monitoring network activities, and so forth. And again, there are various techniques. One thing is to modify the app itself. It's actually a bit tedious, but it's actually very cool and very powerful, where basically you can literally open up the app, and then you just inject a piece of bytecode by hand. This, you could call it also code injection. The other thing could be that you can modify the emulator, so that, for example, the Dalvik VM, instead of just running the thing, is also, when it's trying to jump to a new method, it dumps also what method is executed. You can modify the Android framework. For some projects with my students, we did it, where basically we modify the source code of the framework itself, where basically we add logs, and then we compile it, and we use this modified version. More details about the manual app modification. Again, one of my favorite techniques is bytecode injection. You unpack the app, you add extra functionality, usually it's like a log, and then you pack the app, okay? And example, you want to know what's the value of a specific variable at runtime, and you just literally, you somehow put a line in bytecode, invoke static log, blah, 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 with the specific argument you want to log, and bam, you're gonna log it, okay? It seems easy. It actually is not difficult, but there are many things that can go wrong. So check out the demo on how to actually do this. The usual trick I do for more complex things is I write my own thing in Java, then I compile it and I get my own David bytecode. And then I write my code in a way that is one method and is static, so I don't need to instantiate any object. And then once I have the bytecode, I include it in the APK so that I just put one line in the bytecode injection phase, like invoke static my own method, and now I can do all the logic. So that's a common trick that I use. There are other frameworks that somehow help you out in doing these kind of things automatically. The most popular one is Frida. It can instrument the app itself, so you somehow attach to the app and you somehow do interesting things with it. It's based on code injection, and the idea is that it's a crazy thing. Basically, you attach to the app is injecting a JavaScript engine into the running process, and then you, the user, can specify a JavaScript snippet on what you want to do with this modification, and then this JavaScript engine injected in the target process is going to execute your JavaScript piece of code and instrument the device or instrument the app so that maybe the function calls to X have been logged and so forth. Again, modules are written in JavaScript. One question could be why in JavaScript? And the idea is that it's very portable. There are JavaScript engines for Android OS, many iOS, and many other systems, and so the developers of this decide JavaScript was the way, and it is the way. It's not that painful. I think it's okay, to be honest. And again, it's grown to be the mobile app instrumentation framework. We're gonna have dedicated slides to Frida, so that's why I'm going fast on this. Yeah. So Frida by default requires root because the idea is that Frida basically attaches to the target application, and it needs ptrace to do this. It needs to attach and then inject in the memory this JavaScript thing in its root. The idea, however, is that you can also inject Frida server directly into the target app. So instead of having a Frida server that runs on your phone, and then this Frida server needs to attach to the target app, you can inject this component within the application itself so that you don't need root permission. I never tried it, but here there is a link on how you can do this. Pay attention, in both cases can be detected. And the idea is that if you attach with Frida again is injecting an entire JavaScript engine in the memory space of your application. So if your application somehow scans the memory space, it's going to find that something is wrong, okay? But, as always, if you understand where the app is figuring, oh, there is Frida or not, then you can maybe comment it out, or you can modify it so that it always returns no, there is no Frida, and so forth. Again, armrace kick in. Another famous framework is Exposed. Now I feel it's actually less used. It's a bit more complicated to use. I used it in the past, but again, it's I think Frida is now the winner. And sorry, it somehow instruments the system itself. And again, it requires a root device. It does not touch the APKs. And again, it takes the Android framework and it modifies the Android framework itself so that something happens. Like you log a function called to X, or when X is called, your callback is executed and then you execute the real X, and so forth. There are many user-developed plugins for this, and I put a link there. And again, people use it a lot for small customizations, like changing the color of something or hiding a specific icon somewhere, things like this. Again, fantasy is the limit. But again, for kind of reverse engineering task, I think Frida is the winner here. There are also some kind of analysis frameworks, or sandboxes, where basically there are websites or systems. You submit an app, and then it's going to analyze it, and then a report is produced, and you see what the app has been doing during this analysis. For example, you can list the URLs contacted, the DNS queries, API traces, and so forth. Cuckoo is a famous sandbox for, I think, Windows malware. I don't know if it's also Linux malware. I don't remember. but there is also a variant for Android. And again, it's open source. The link is there. And again, the idea is that you run it in an environment where they trace things like, you know, which files you're opening and so forth, and then you get a nice report in return. There are also professional or, you know, industry level sandboxes. One of the famous one is Joe Sandbox. There is an online service, and they're very cool. I mean, they're very, very cool in the sense that you just submit an application and then it does some kind of analysis, and then you get a report. In the past, I think it was a certain public submissions. Then they got pissed that they were, you know, people were playing with them to try to understand, try to write an app that understands, hey, I'm under analysis of this specific sandbox. I'm not sure it's possible right now, but, you know, it's a very popular solution for many companies. Again, there is a link there for an example report. As you can see, it's I mean, it's very, very detailed, and it's very, very cool. And of course, it's always the same arm race, because malware maybe tries to figure out, hey, I'm under analysis under Joe Sandbox, so I'm not gonna execute malicious application XYZ, malicious behavior XYZ. And again, if Joe Sandbox developers figure this out, then they can adapt and they can modify the way that the malware was, you know, the specific aspect the malware was trying to retrieve to then bypass this anti-debugging or anti-instrumentation check. Okay. And again, the tricks that the malware uses to detect this kind of environments can be very basic, and they can be very, very effective. So in my previous university at UC Santa Barbara, my group was basically in charge of running Anubis, which was a malware analysis sandbox to analyze Windows malware. And then we kicked in with some colleagues, and we wrote Andrubis, which was the, let's say, the Anubis plugin for Android app. Now it's been discontinued since several years, but, you know, it was a big thing at that point. But I remember some stories where malware was were detecting, hey, I'm running within Anubis, oh, and then I don't do anything. And some of the tricks were, they would check if the username was Andy, and if the username was Andy, then they wouldn't do anything. Why? Because it's Anubis virtual machines for Windows, they were always running with username Andy, and that's why then they said, okay, screw Andy. Now they do a randomized username. Another trick was, oh, you know, we run on a machine and there are no files around. How is it possible? That's probably not a real user machine. And so the malware would escape analysis. And now as a reply, now normal sandboxes usually create a bunch of fake files in this emulated environment so that the malware cannot easily understand it is a fake machine or not. There are a gazillion of different ways to detect virtual machines or, you know, analysis systems. And again, it's an arm race of the bad guys trying to detect these systems, and the developers of these systems try to stay undetected. There are more resources listed here. They are actually very, very cool. There is this Android app reverse engineering 101. It's done by Maddie Stone. Is a researcher at Google. She's great. And there are also some videos on the analysis of, you know, how to dig in some specific aspects. So strongly suggested. There are other links on, you know, kind of overviews of these reversing engineering things for Android. Some links again on this guy that reverse engineering the app for the vending machines, and somehow got something for free and also been trained to be sued. And there is also a link to Frida things, but again, I have a set of slides on this Frida thing, so that's why I skipped over it a little bit. But, you know, it's a very cool tool, and we're gonna have some more slides on this. All right, that's what I have. Bye bye.